In this module, we are going to discuss about thermogravimetric analysis. Thermal analysis. When matter is heated, it undergoes certain physical and chemical changes. The physical and chemical changes takes place over a wide temperature range. Melting and boiling are physical changes. They occur at widely varying temperatures depending on the material involved. Chemical changes such as decomposition or reaction may also take place at different temperatures. The physical and chemical changes that takes place when an unknown sample is heated, it provides us information that enable us to identify the material. These changes also indicate the temperature at which the material in question ceases to be stable under normal conditions. This information is very useful to industrial chemists, those who make varnishes and paints, since it allows them to predict the service lifetime of such compounds. Thermal analysis is a method by which the change in physical and chemical property of the chemical substance is determined and recorded as a function of temperature. Three groups of physical parameters to be measured, that is mass, temperature or heat flux, mechanical and other parameters, allow for a classification of the thermal analysis method. Thermogravimetric analysis measures mass changes in a sample as a function of temperature or time under a controlled atmosphere. In differential thermal analysis, the difference in temperature between the sample and a reference material is monitored against temperature or time. Differential scanning calorimetry is a thermal analysis technique in which the heat flow into or out of a sample is measured as a function of temperature. Dynamic mechanical analysis measures the change in stress or strain under uniform stress or strain that remains constant across time. In thermal mechanical analysis, the deformation of the sample under non-oscillating stress is monitored against time or temperature, while the temperature of the sample in a specified atmosphere is programmed. The stress may be compression or tension. Thermo-optical analysis permits the visual observation of the physical changes produced in a sample as a function of temperature or time. Evolved gas analysis used to study the gas evolved from a heated sample that undergoes decomposition or desorption. Thermogravimetric analysis. The word thermo refer heat. Gravimetric refer gravity. Analysis refer measuring the change in weight with temperature change. It is an experimental technique in which the mass of a sample is measured as a function of sample temperature or time. This is the basic principle of thermogravimetric analysis. The sample is typically heated at a constant heating rate, so-called dynamic measurement, or held at a constant temperature, so-called isothermal measurement. Only solid substances can be analyzed by this method. Thermogravimetric analysis is abbreviated as TGA. In TGA, there are two changes are possible. The first one is the reactant, which is a solid when heated produces product and gas emitted out. And the second change is reactants combine with gas at high temperature to produce product. Usually, we do not perform the second type of change in the lab. The first type of changes involves the loss in the mass or weight. This loss may be due to the gas which is obtained by decomposition of reactants on heating, or loss may be due to water molecules present with the reactant. This water is essential water. The essential water is water of crystallization, or it is water of constituents. There are three cases. The first one is the loss in weight of the substance is due to gas. Example, when calcium carbonate heated, it produces calcium oxide and carbon dioxide. Secondly, the loss in weight due to water of crystallization. Example, copper sulfate pentahydrate on heating produces copper sulfate monohydrate and 4 molecules of water. And third, the loss of water due to constituent. Example, ferric hydroxide on heating produces ferric oxide, which is a solid, and 3 molecules of water are liberated out. Thermogram. The graph is plotted between mass versus temperature or time. The graph thus obtained is known as thermogram. Thermogram is characteristic curve for a given compound. In this graph, the horizontal portion, that is the plateau, indicate the region where there is no change in the weight, while curved portion indicates the loss in the mass. The heating temperature varies from ambient to 1500 degrees Celsius. The instrumentation of TGA is consisting of few components: balance, furnace or heating device, sample holder, temperature measurement and control unit, recorder. The first and the important is balance. It must be highly sensitive analytical balance. It must be precise and accurate at experimental temperature. The commonly used balance is Kohn electrobalance. It functions as null type device by providing an electrical force to restore the beam to be predetermined position. When mass changes, the beam of the balance changes. A shutter fixed to the beam changes the amount of light reaching the phototube, which causes a restoring force to be generated by passing a current through an electromagnet that serves as the pivot for the balance beam. A permanent magnet above and below the pivot provides the magnetic attraction to the electromagnet. The force required to restore the beam is proportional to the current which is recorded. Secondly, furnace or heating device. Here the sample is heated by resistance heater, IR radiations, microwave radiations, or heating can also be done by passing the hot vapors of liquids or solids. The furnace must be designed in such a manner that heat produced is directly given to the sample. The rate of increase of temperature must be 0.152 to 2 degrees per minute. The heating should be done in such a manner so that the weighing system should not be affected. Next is sample holder. The sample holder should be made up of glass, quartz, stainless steel or platinum. The size and shape depends on the weight and nature of the sample. Next is temperature measurement and control unit. The temperature measurement is done by thermocouples. It is placed very close to the sample. The EMF generated by a thermocouple when heat is recorded, and it is applied on the x-axis of the data acquisition and manipulation system, that is computer. Recorder. The recording system are mainly of two types: time-based potentiometric strip chart recorder and XY recorder. In some instruments, light beam galvanometer, photographic paper recorder, or one recorder with two or more pins are used. One main advantage of these recorders is that one can check the heating rate of the furnace for linearity. In the XY recorder, we get curve having plot of weight directly against temperature. In most of the instruments, the normal mode of recording data for thermogravimetry is the weight change versus temperature or time. Next is control of atmosphere. The result of thermogravimetry depends on the atmosphere of sample. See that the atmosphere should be inert gas called purge gas, which may be argon or nitrogen. Let us discuss the working of this instrument. First of all, temperature of the sample is censored by the temperature sensor, that is thermocouple. This temperature is sent to the computer and the computer sends information to the temperature controller to increase the temperature. Hence, temperature of the furnace increases and the sample may undergo decomposition. It loses some weight. It becomes lighter. So the pan of the balance move upwards and the reference weight move downward. During this movement, this mirror attached to the balance reflects the light at a certain angle. This deflection in light beam is recorded by the computer, and the computer again sends the required amount of the current to the magnet, so that the reference weight is again move in upward direction and the mirror move its horizontal position. The amount of current supplied to the magnet depends on the weight loss. So finally, this is converted to a weight loss of the system, and which is recorded on the graph in y-axis, while temperature is recorded on the x-axis. Finally, we can get a graph of loss in weight versus temperature or time. Some factors affect TGA curve or thermogram. There are heating rate, the heat of the reaction, furnace temperature, the geometry of the crucible, and the characteristics of the sample. First is the heating rate. When a substance is heated to the faster rate, the temperature of the sample becomes high. It means temperature changes, and as thermogram depends on temperature, so the thermogram changes. Second is the heat of reaction. It depends whether the reaction is exothermic or endothermic. It means The heat changes, so the thermogram changes. Third, furnace atmosphere. The nature of the surrounding atmosphere can have an effect on the temperature of decomposition. For example, instead of nitrogen, if carbon dioxide is used as surrounding atmosphere, the decomposition of calcium carbonate takes place at the much higher temperature. Calcium carbonate undergo decomposition at high temperature to calcium oxide and carbon dioxide. As the carbon dioxide is on right hand side, so the reverse reaction takes place. So the nature of thermogram changes. It means whenever furnace atmosphere is enriched with one of the product of the reaction, the decomposition temperature changes and so the nature of the thermogram changes. Fourth, the geometry of crucible. The geometry of crucible can change the slope of the TGA curve. Usually, flat-shaped crucible is used because the diffusion of gases evolved is easier. And last, characteristics of sample. Characteristic means the amount of sample, particle size, packing density, the thermal conductivity of the sample, the mode of preparation of the sample, and the atmosphere around it, which also influence the thermogravimetric curve.